Let's discuss the periodic table. So this is a table whereby elements are arranged according to their atomic numbers. You know the number of protons that they have in their atom. So the arrangement is in order of increasing atomic numbers, starting from hydrogen that has the atomic number of 1 and ending with lawrencium that has the atomic number of 1 or 3. Now these elements are placed in vertical columns and horizontal rows. So the vertical columns are referred to as groups, while the horizontal rows are called periods. Now let's start with the groups. So each group contains a family of elements. Now there are 8 groups in total. These are designated with 1 to 8 using the Roman numerals, of course. So this is group 1, group 2, 3, 4, 5, 6, 7, and 8. Now the elements that are present in one group have the following features in common with one another. Number 1 is that they have the same number of valence electrons. Number 2 is that they share similar physical and chemical properties. Okay, let's break that down. What do we mean by valence electrons? These are electrons that occupy the outermost energy level. Let's take an example of group 2. This is where we have beryllium, magnesium, and calcium. So beryllium has the atomic number of 4. So 4 protons, 4 electrons. So how are we going to arrange the electrons? In their energy levels, of course. The first energy level can take a maximum of 2 electrons. Other energy levels can take a maximum of 8. So we're going to have 2, 2. Moving on to magnesium. This has the atomic number of 12. So 12 electrons. And we end up having a configuration of 282. Lastly, calcium has the electron configuration of 2882. Are you seeing the trend with these? They all have 2 valence electrons, and as such, they belong to group 2. Now, such elements are going to have similar physical and chemical properties with one another. So the way they are, the way they react with other elements or compounds is going to be similar to one another. Moving on to the periods. Now, elements that belong to the same period have the same number of energy levels. So let me take an example of period 2. This is where we have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. What do all of these have in common with one another? They have 2 energy levels. And this is the reason why they belong to period 2. Elements that belong to period 3 will have 3 energy levels. Going back to our example of magnesium. Magnesium had the electron configuration of 282. So those are 3 energy levels. Sodium has the electron configuration of 281, 3 energy levels. Chlorine 287, 3 energy levels. So all elements belonging to the same period have the same number of energy levels. A few things to note about periods. Within a period, the elements are arranged in order of increasing atomic number. So moving from left to right, the number of protons is going to increase. For example, in period 3, you're going to have sodium that has 11 protons, and as you progress, the number of protons increases until you reach argon that has 18 protons. Now, the first element in any period always has 1 valence electron. For example, in period 2, lithium is the first element and it has 1 valence electron. In period 3, it's sodium, same, 1 valence electron. In period 4, potassium, again, 1 valence electron. And the last one, in that particular period, will always have 8 valence electrons. Now, one last thing, and this I believe is very important. Sometimes students have a bit of a challenge in remembering whether the groups are the vertical or horizontal ones. I have a very easy solution for you. I want you to write down the term period and group on one side, and on the other side, horizontal and vertical. You're going to choose the 2 words that have the most letters from each group and match them together. So period and horizontal have the most letters and therefore they belong to one another. So period, these are the horizontal ones, while groups, vertical ones.